Greetings to all of you in this session of celebration for DAE Iconic Week for Azadi Ka Amrit Mahotsav. This whole week is going to be not only very eventful, but also full of new experience to all of us, and we hope that today's program will not be an exception. Lectures by eminent scientists and archaeologists, followed by a culture program, is surely going to make this day memorable for us. To start with the program, I'd request Dr. Vaishali Naik, chairperson of today's event, for a welcome address.
Good afternoon, everyone. On behalf of the organizing committee, a very warm welcome to all of you. On the third day of DAE Iconic Week celebrations of Azadi Ka Amrit Mahotsav. Respected dignitaries, colleagues, and students, as we celebrate 75 years of our independence, moving past the recent devastating pandemic and uncertainty due to the war in the neighborhood, all of us are looking forward to a glorious next 25 years with hope and resilience as we move towards the centenary celebrations. So it is most appropriate that we also look back to our history for lessons for the future. As all of you would agree, history, when scrutinized with solid scientific tools, becomes undeniable evidence. So today, we are glad to have with us two eminent scientists who are masters of this field to speak on the topic. Professor Anindo Sarkar, a well-known geophysicist from IIT Kharagpur, and Professor Vasant Shinde, celebrated archaeologist from the famous Deccan College in Pune, will take us through their journey of the Indus Valley civilization. We shall be ending today's Utsav on a musical note with the performance of music band Madul. So once again, I thank all of you for joining us and also thank the speakers for kindly accepting our invitation.
A very good afternoon to all of you. At the outset, I must thank Professor Shom for inviting me for this lecture. And I also saw in the program today that Professor Vasant Shinde, who is also very well-known archaeologist and a long-term, in fact, he's also a kind of collaborator with me. He will also be giving a lecture after this. Now, I must tell very candidly that I am not an archaeologist. Okay, I'm basically a geoscientist, not a geophysicist per se. I'm basically a geologist. And broadly, I work in the field of present and past climate change. And of late, I have been interested in geoarchaeology. I'll be telling you that what drove me to this field and why I thought that it could be an interesting field to pursue to such a later part of my career. Now, if you look at, for example, the geological time scale, you know that I would be confining to, let us say, only last 2 million years. That is the time when basically the genus Homo appears as a carnivorous scavenger, hunting, gathering started, and then there was a series of evolutionary changes of these homos. For example, the Neanderthal appears, the invention of the clothing, some kind of, very elementary level language, sophisticated cognition. And then it goes on, you have the very early cultivation somewhere between 12,000 to 9,500 BCE, early farming, cultivation of barley and wheat, for which the evidences are found, especially in the Pakistan region and some part of the Middle Eastern countries. And then, of course, you have these so-called Chalcolithic phase starts. Incidentally, you just add around 2,000 years, so 3,700 means geologists, we always want to talk in terms of before present. Archaeologists want to talk about, before Common Era or Christian Era, things like that. So you have the first Mesopotamian writing, Stonehenge construction. If you go to the England, you will be seeing. And then comes very extensively contemporary several old world civilizations, including the Indus Valley civilizations, when the mankind for the first time started building the cities. Okay? And from there on, you enter into the Iron Age, painted gravers, and then you enter into the classical, medieval, and the modern histories. So this time span, that this is a spectacular time span in terms of the events, if you consider. The Earth had developed extensive polar ice caps, which you see today, for example, Antarctic and Arctic ice sheets. And there are also changes in climate in a very major way, okay? And this kind of rapid evolution of the Homo sapiens always provoked people to probe that whether climate had anything to do with this human evolution. Because you must understand that from somewhere here, hunting-gathering system, you go to building the cities, it requires certain evolution of the brains. And many anthropologists have always conjectured that probably climate can be a triggering factor, thereby you accelerate the evolution of the brain, and therefore a variety of activities mankind start doing. But this time period, geologists have been studying from a different angle. Purely from academic viewpoint, they were studying it for knowing the climate changes, what was happening here. Okay, for example, I just give one example. This time period, somewhere around 10,000 to 7,000 years before present, we had a very warm Earth. Okay, the relative sea level was much higher, and that is the time when the mankind started, spreading, migrating from one continent to the other, and whole lot of things happen. So geologically, we call this period, the lower part we call it as a quaternary, and the last 10,000 years we call it as Holocene. So that is one driving part, because I have been working in this time scale purely for climate studies over the last 20-30 years. But that it also kind of overlaps or coincide with the human evolutionary traits also led me to probe that why not try to see some of the old human settlements and also simultaneously try to understand the climate from different archaeological settings. So that was one driving, or motivation, you can say, for studying these time scale. The other one is, of course, is a bit societal problem. That if you look at not only in India, if you look at this ancient time, people have conjectured many things. Okay, in the sense that is not only confined to India alone. If you go to the US, there is a lot of people believe that the Darwin's evolutionary theory is bunkum and the creationism was the kind of thing, okay? So the India is no exception. For example, you have heard time and again in the newspaper that there are claims or there are kind of quasi-conjecture that India had ancient Indians knew how to construct, fabricate aeroplanes, and aeroplanes in the Vedic age could fly between planets, and the conjectures like that, the Vedas could be somewhere 6000 BC, means 8000, 9000, 10,000 before present. And as just now I have showed you, that was a time period when basically mankind was a hunter-gatherers. Okay, they were living in caves. So the pushing the Vedas to 10,000 years, which is when the language even was not properly framed. These are the things where, you know, in a way you can say that that there is a blurred boundary between mythology and the science. Okay, so therefore these two you know, motivations. That one is that a time frame which is very conversant to me as a geologist, that this is the time frame where I was studying the climate, and then these that if some of these human evolutionary traits can be studied from scientific angles rather than some kind of conjectures and or flimsy ground. And today's archaeology it has come a long way actually, you know. That today, as you can see, this is a very famous journal of archaeological science, where today archaeologists use, or the scientists use, almost all the modern technologies what is available under the roof. Okay, let me just give you few examples. How does one unravel the mystery of the past? Okay, this is, you know, a few years back, there was a large megapolis which was unearthed below the Guatemala jungles, which is now dated to be somewhere around 4,000 years old. Now, this was completely covered, and nobody knew, okay, that such a magnificent city was, megapolis was there. And how did they discover? They used basically a technique which is known as the LIDAR, that is light detection and ranging survey. Sorry. What happened? The previous one. Okay. No, I'll be handling. Don't worry. I'll be doing. I'm doing. Huh? Okay. Okay. So this technique is actually used conventionally by geoscientists, geographers who are studying, for example, the landforms, various kinds of subsurface structures which are available in the earth. So this was a standard technology, airborne technology via GPS, which they were using in other fields. And this technology is now being very extensively used for studying what you call the archaeology also. The other one is that these, you know, the conventional archaeological things, that is the excavation as the archaeologists do. This is, for example, the archaeological mound at Dholavira. Okay, as you can see, this was the mound before, you know, excavation, and as they are excavating, they are gradually unearthing the city. Okay, I'll be discussing about this in a very great detail. So, and once they find out such kind of human settlement, they start excavating below. It's a very time-consuming job, labor-intensive job. It requires a lot of money. For example, the Indus Valley city, Dholavira in Gujarat, the excavation they started in 1990, and it went for almost 15 years, okay, to unravel these. So you can easily imagine that in the earlier part of the century, the discovery of the Harappa and Mohenjo-daro, if you go to the history, they took nearly 20, 30 years. Even now the excavations are going on at selected places. Now, what do you do once you find out an archaeological remains? The first thing one would like to know that how old it is. And you utilize very conventional, what you call the radiocarbon dating facility, okay? The cosmic rays are hitting the nitrogen, they are getting converted to 14C, has about 5,000 plus half-life, it gets decays back, and it enters into the food chain. For example, these are some of the carbonized cereal from Indus Valley civilizations, the wheats or the rice which have been completely carbonized. And then these radiocarbon can be measured by accelerator mass spectrometer today. This is a physical research laboratory accelerator mass spectrometer facility, and this has been our kind of backbone for generating the radiocarbon date at different Indus Valley civilization site. Okay. The other way, now sometimes one is not that lucky to get, for example, these cereals. Okay, you may not get always. Okay, so but still you need dates. So how do they date these? What you get in archaeological remains, like as it is shown here from Sanauli, UP, you also get what you call this kind of potteries. Okay, this kind of potteries. You see there is a skeleton, you get this kind of potteries. Now these potteries are made, as you know, today if you go to these, the people who make these pots, you know, they fire it at a high temperature. And that actually gives us a tool which is today known as optically stimulated luminescence dating technique, which basically uses the counting electrons trapped in burnt artifacts, and essentially by which you can, what you can do, you can tell exactly how much time elapsed since this pottery has been made. So wherever you get the cereals, like what I showed, you date them. Wherever you get these potteries, you date them. Sometimes you do not get either of these, you try to date something else. For example, the animal bones or what you call the human skeletons and things like that. Today I will be principally focusing on use of isotope tracers in, you know, the archaeological science. And when you say isotope is a big field, this is a center of studying isotope. I will be talking about mainly the isotopes of lower masses, okay? For example, the oxygen, hydrogen, nitrogen, carbon, sulfur, and things like that. And even there, if you look actually, you see that they have a vast, you know, applications. For example, you can study the planetary evolution by using isotopes of oxygen and hydrogen. You can do oil exploration by studying carbon and sulfur isotopes. You can study climate change by using oxygen and carbon isotope. Medicine, for example, very extensive use is found in medicine using of oxygen and hydrogen isotope. In agriculture, you have nitrogen and carbon because they are taken up by the plants. They can be fingerprinted very nicely. And of course, forensic science, nitrogen, oxygen, and carbon isotopes are used very extensively. And there's the same technique which forensic science actually use are also used in the archaeology. So what I will be principally concentrating today is neither nitrogen nor the carbon, because they essentially talk about the food and the evolution of the dietary behavior of the animals or the human being. I will be principally concentrating on isotopes of oxygen, which we use as a you know, principal tracer for understanding the evolution of the you know, ancient settlements. Now, you know, this is a like a detective fingerprinting. Okay, if you go today to Washington D.C. And go to the FBI office, they have today this kind of mass spectrometers which measures oxygen and hydrogen isotopes. Why do they do it? This is a case of, you know, the mystery of Little Miss Lake Panscoffey. A small girl was found killed in the east coast of USA, and the police was trying to find out where from she comes. And then what they started doing, they started analyzing the teeth, they started analyzing her hairs and things like that. And those teeth and hair and the isotopes in them actually contained the information from where the person came. Okay, how you may be wondering that how that can happen. You know, principally they use a variety of mass spectrometers. These are some of the mass spectrometers in our lab at IIT Kharagpur, where we study oxygen, carbon, hydrogen, nitrogen, and sulfur isotopes. And it can tell you a lot about climate, vegetation, migration, including the human migration. And simultaneously, we also do chronology by using you know, isotopes of varying, you know, half-lives. Depending on your problems, you choose. If you are going back to a million year time scale or billion year time scale or planetary evolution, you use isotopes something like this, which is 4.5 billion years old. And if you are trying to look at processes which are very short-lived processes, you use this kind of isotopes. So these are basically our, very super clean rooms and the radiogenic isotope laboratories. So we analyze all these materials there. And in archaeological perspective particularly, what are the samples we get? As I said, that just like forensics, we get bones. This is a skeleton which has been found in one of the Indus Valley civilization site. You get teeth, you get snail shells like this, which is basically calcium carbonate. And you can go to time depth from million years to basically recent, okay? And this is basically a deer teeth, and this is basically a cattle bone from a place called Virana. I'll show you one or two, some data which I will show you, which might be interesting. Now, if you look at the bone, bone is a composite material, that is, it has about 68% hydroxyapatite, and as you can see that it has carbon that actually contains the information what this animal was basically eating, but we are more interested in the oxygen, okay? And that is what we try to extract, and particularly the phosphate being a very, very tough radical, so a whole lot of chemistry has to be done so that you extract the oxygen, convert them into gas at a very high temperature burning, and then you can study the isotopes of oxygen in those phases. In addition to that, as I said, that you can also analyze calcium carbonate, which also contain carbon as well as oxygen, and you can use them for variety of processes. Okay. So summarizing, let me just summarize that what isotopes can do. If you want to study past climate, isotopes, yes, can be used as tracers. When we say past climate, what do I mean? If you talk about the modern climate is a very complicated system, For example, if you look at the monsoon system, it not only involves temperature, or sea surface temperature or land temperature, not only it involves, for example, the amount of rainfall which is taking place, but it is also very intimately connected to the wind stress, wind speed, geopotential height, whole lot. And that is why, the Indian Institute of Tropical Meteorology, they have to have a supercomputer to predict the monsoon, okay, onset and when the monsoon is basically returning. In the past, we do not have that liberty. We cannot get so many parameters. So what we can do, we can at best get idea about rain, how much rain was taken, rain was there, or if rain was not there, there was a drought, or we can talk about the temperature, that at what temperature any organism was living or a mankind was living. And of course, you can talk a lot from carbon and nitrogen about the paleo diet, okay, what we were eating in the past. Now, let me just give you one show you one cartoon that how isotopes get, fractionated, okay? For example, when we talk about the oxygen isotope, it has 3 isotopes. One is 16, and there is the 17, and there is the 18. If you look at the abundance, the 17 is a very small abundance, okay? It's extremely difficult to measure, okay, in natural system, okay? Although in our lab, we have been able to measure now even that, and that is another dimension. But conventionally, people study these isotopes, oxygen 18 and oxygen 16. One is heavier, another is lighter. Now, when the evaporation takes place, obviously, the quantum mechanics demands that the vibrational frequencies are such that the molecules which are going into the vapor phase, they will be concentrating more lighter isotopes compared to the what you call the liquid phase, which is heavier and left below. So what happens if you start with a value of 0, and the notations of isotopes are such, we explain them in terms of delta, which is nothing very great, which is the heavier to lighter isotope ratio with respect to a standard. What standard? It is the International Atomic Energy Agency at Vienna. They supply to all the laboratories across the world, and they use it as a standard. So this delta value, if you just take, you see that this becomes 0 becomes minus 10, essentially meaning that it has concentrated more of 16O, okay? And this vapor, when it is moving towards the continent as it is happening now, for example, in the monsoon time, that the moisture from the Arabian Sea or the Bay of Bengal is lifted up, and then they are dragged towards inside the continent, so it keeps on raining. Now again, when they are raining, there is a phase transition. So there is a vapor to solid, liquid phase, and then in the liquid, correspondingly the heavier isotopes fall, and the remaining vapor becomes further concentrated in lighter isotopes. So this unique, very simplistic picture tells you that by using isotope, you can do two things. One is the fresh waters isotopically are much more negative, okay, because it has much lighter isotope concentrated, okay, and the marine waters, they are much more enriched, okay. Just the reverse happen if you have an evaporation. So if you continuously evaporate, the lighter ones will go out and the heavier ones will remain. For example, if you go to the Thor desert, there are some saline lakes. Those lakes will be heavily concentrated by, will show heavy concentration of heavier isotopes of oxygen. Now, by the time you reach here and go to the mountains, you become you get extremely negative, fallout of these rain. And when you go to the, for example, go to the top of the Himalayas, those rains get converted to ice. So therefore, the ice itself is an extremely negative kind of values you will be finding in terms of the isotope systematics. So whether you go to the Antarctic, whether you go to the Arctic, or whether you go to the glacier ices are extremely negative in terms of the what you call oxygen isotopic composition. The fresh waters are a little more positive, and ocean waters or evaporative waters are extremely positive. So it gives you a tool to differentiate, the kind of water which was there at a particular place, which any organism or any mankind was either drinking or while living in, okay. So just to show you one animation, this is what you can see is a monthly weighted oxygen isotope throughout the globe. This has been mapped by many people. The International Atomic Energy Agency, they have, the measurement stations at different places. We have in India, we have two places, where one is in Bombay, one in Delhi, and they have been measuring for last 60 years the isotopes of oxygen, and therefore they have been able to generate this kind of map. What it shows you that even at monthly scale, the scale is from -2 to -30. And remember, our experimental precision in mass spectrometers are 0.1 per mil or better than 0.1 per mil. So it's a large variation, as you can see, you are finding on a monthly basis globally. So each area is characterized by a specific isotopic composition of water. So when I was talking about the little kid who was murdered and whose body was found in the East Coast, eventually the FBI investigated and they found out that she actually belongs to the West Coast, because the water in the West Coast of US is completely different compared to the water in the East Coast of United States. Here also in India, the water which is there in Rajasthan, which is an arid area, highly evaporative area, where the rainfall is very low, is quite different than the monsoonal areas like Bengal or Bihar or the central India. So that is the kind of very basic idea by which we use it. So how does it work? You have mammalian bone, tooth, or calcium carbonate, delta 80, and this delta 80 is equal to the drinking or ambient water oxygen isotope, and drinking or ambient water oxygen isotope essentially depends on the rainfall, okay, and this mammalian bone, tooth, or shell oxygen isotope essentially talk you about the rainfall conditions, okay, and by this treasure you can even kind of quantify also that how much rain had taken place in the past, okay. But remember one thing, that when you are analyzing a bone or a skeleton, a man lives, let us say 60, 70 years, a dog will be living 10 years or so. Whatever skeletons you get in archaeological remains, you will be getting a kind of integrated rainfall information at that place over its lifetime. So it will give you a rainfall information for 100 years or 10 years or something like that. But what if I want to know at the seasonal scale, okay, that I want to know that, let us say 500 years back, how the season was like, okay. For that you require an archive which can record that seasonality, and also you require an experimental technique by which you will be able to differentiate that seasonal variation at a very micro scale, okay. Not a very easy job, but still people started doing it by analyzing a variety of systems. One of those are something like this. This is what we did very recently. If you, at least Bengalis would be knowing, if you eat a fish, the fish has a ear bone, okay? Fish has a ear bone, okay? especially if you eat VECC fish, it will hit your mouth. So it has a ear bone. That ear bone would be hardly half a centimeter, okay? And if you make a polished section, you will see these growth rings, okay? And that growth ring means that when the fish was born or the juvenile stage, it started its life here, and as it grew, these were growing like this, almost like a rings of tree, almost like a rings of the coral. The same thing can be done. But remember that this is a very small dimension. So therefore, we could not have done it physically as we do for a bone or things like that. A bone is a big material. So I can drill, I can take the sample, I can do whatever chemistry I want to do. But for this, it would not have been possible to do that because it itself is so small. And if these layerings are essentially indicating some kind of climatic perturbations, so there was a technique necessary for developing at that micro scale. And that is what we had developed over the last 2-3 years at IIT Kharagpur. We have been able to use laser, CO2 laser, which has a beam of something like 50 micron. So it can analyze a large number of samples, and thereby it can retrieve the climate during the lifetime of a fish. So if a fish is living for 2 years or 1 year, so you can talk about the seasonality during the existence of the lifetime of the fish. And why fish? Because many of the archaeological sites, they have this kind of fish remains. They are typically, conventionally, the fisheries people call them as otoliths, and they are found plenty because the ancient settlers, they were eating this kind of materials, this kind of fishes very frequently. So you have this kind of layerings, okay? When you analyze it, you get this kind of wriggles, okay? This is from an Indian Ocean. As you can see, if you look at the temperature of the Indian Ocean, it varies, in the winter time, 28 degree to something like about 30, 31 degree. So there is a distinct seasonality, okay? You can see that October and so on and so forth. And these temperature is actually recorded in these, shell materials, okay? In these shell materials. So this is a this is a laser system at IIT Kharagpur, which we use almost on daily basis to determine the seasonality of this material. So basically, my point is to tell you that you can talk about a annual level climate, you can talk about decadal level climate, you can also talk about seasonal level climate depending on what is your requirement, okay? What is your ultimate goal. Now let me just take you through few journeys of where we have applied these techniques, okay? Now, many of you must be knowing, those who are interested in history, that if you go to Mediterranean region, we had what you call the so-called Assyrian, kingdom, the Babylonian kingdom and things like that, the Egyptian kingdom and all these things, okay? And these empires, people were very much interested for a long time that you have a Persian Gulf here, you have a Mediterranean Sea here, okay? Whether they had any kind of connections, there were trade exchanges or not, whether there was a maritime trade, whether the trades were coming from Persian Gulf, whether the trades were through the routes of the Mediterranean Sea. So this was one of the questions which apparently archaeologists are much interested, okay? And that is why the University of Haifa, actually when they approached us, we were very happy to collaborate because by that time we had developed the technique. And this is the tail door, which is the coast of the Israel. This is the archaeological sites, okay? This is the archaeological sites in the Mediterranean. Now, when they were excavating these, they find this kind of fish teeth. You find this fish teeth even today, but they were using it in the ancient time also, okay? And we extensively studied the isotopes with these and eventually came to a conclusion that this tail door site was trade-wise connected both with the Persian Gulf and with the Red Sea via the Mediterranean. Why? Because the salinity or the freshening of the water of Mediterranean, Persian Gulf and the Red Sea are completely different, okay? So therefore, each having a distinct origin, and the fishes which were being taken from here, they were taken from here, taken to the tail door, or sometimes from Red Sea, taken to the tail door, and one can very nicely actually talk about these trade routes, okay? This is just one of the tracers which I mentioned. There are many isotope tracers by which people are trying to study what you call this kind of connection of the trade route. This brings to the main topic today, which is the mysteries of Indus Valley civilization. Now, we typically call them as a Bronze Age civilization. The typical age is 5,500 to 3,500 years before present. But I must also tell you that you had some old world contemporary civilizations. For example, Yangtze River in China, you have the Egyptian civilization, Mesopotamian civilization, and so on and so forth. Almost contemporary civilizations. Okay. Now, what was the reason that this civilization came into existence, and what is the reason that the civilization suddenly collapsed and disappeared from the earth? Okay. This is a mystery which people have been asking for trying to probe for a long time. Many theories have come up, okay, last 50 years. One of the theory was the prolonged drought. Other could be interpersonal violence, okay. The people found that large graves and cut marks in the, what you call, skeletons, or even sometimes, infectious disease has also been invoked for elimination of these civilizations. So many things have been suggested, okay. But none of these theories actually can kind of completely or conclusively say that this was the reason, okay. So what did we do about 5 or 6 years back? We wanted to go to a archaeological sites of Virana, Haryana, and this is what is when the excavation was going on, where it occurs somewhere here, okay. It occurs somewhere here. This is your Harappa, okay. This is your Mohenjo-daro. This is the Indus River, and that is why the dots are nothing but the civilization sites, big settlements or the small settlements. The Virana is here, Rakigori is here, on which Dr. Sinde is going to talk today. And interestingly, as you can see, this is all around the periphery of the Third Desert. All around in the periphery of the Third Desert. This was a place which was excavated long back by archaeologists of Archaeological Survey of India. And they kind of predicted or tried to tell, based on the archaeological evidences, that this could be very old, even older than contemporary civilizations known elsewhere of the Indus Valley settlements, okay. So, as I said, that is something like 5,500, 5,300 years, things like that. So, we went there, but unfortunately, this site was excavated, it was covered. So, we had only the materials. We had only, for example, these potteries, we had bones, and things like that. And we could never have the access of collecting the samples as the excavation was going on. But nevertheless, let me tell you what we found out. This is a monsoon record from the Arabian Sea, okay. This is a monsoon record from a lake which is very close to the settlement of Virana or Rakigori, okay. It's a lake where they drilled and they found out. And this is from the archaeological site itself, okay. First thing we did, as I do always, that I go for dating, okay, because not many dates were available. And when we started dating, we find that conventionally, if early Harappans or the early Indus Valley people started their habitation around 5,300 years, this is a place where probably the early Harappans could be as old as 8,000 years, okay. That is the kind of things we got, okay. And instantly, it looks that probably this conventional idea that everywhere the Indus Valley civilization has to start at 5,500 years may not necessarily be true. Brings to a question that whether the cultural evolution is time diachronous or time synchronous, okay. Most likely, it should be time diachronous. I don't think that it appeared all at a time. It could collapse all at a time, but it appears all at a time. In the biological world also it doesn't happen, okay. And in human evolution and things like that also it is very unlikely. Anyway, now this early Harappan time, the blue shaded region, is basically a time when the monsoon was very strong. That is the time when the Harappans came into existence and they started building the cities and things like that. But as the time progressed, the monsoon started going down. The lake level, for example, was very high. The lake level started going down and suggesting that probably the monsoon over Indian subcontinent was slowing, okay? It was going down and down. Interestingly, although the monsoon was going down, but you can see the Harappans were basically continuing in their endeavors, going through early mature Harappan to the mature Harappan when major cities were built all across the subcontinent, okay? Meaning what? Meaning that these Indus Valley people could survive in spite of a decreasing monsoon over 1,000-year time scale, okay? And they did not disappear just like that. And the question obviously brings that what could be those factors that led them to sustain for more than 2,000 years? Because eventually the late Harappans end somewhere around 3,500 years or something like that. Now, there are many indications. One of the major thing which is coming very prominently is that, when the monsoon was good, they were basically growing, water intensive crops like large grain cereals, wheat, barley, probably rice also. And when the monsoon started becoming weaker, they started growing, they switched over the crop pattern. They started growing what you call the drought resistant small grain cereal or millet. Even today you go to the Western India where the rainfall deficit is there, millet is one of their main food source. So they basically what you call they switched over the crop pattern for sustaining these things. Very interesting, although that almost 2,000 years rainfall is coming down, they are switching over their crop patterns, they are not dying, they are not leaving their settlements. And that actually gives us a great deal of motivation that today the climate change is so serious that a 200-year-old modern civilization, human civilization, as Stephen Hawking says that it is going to be extinct in another 300, 400 years. But here is a striking case that the Indus Valley people could survive against the onslaught of what you call the decreasing monsoon for almost 2,000 years by doing this kind of ingenious thing, that changing crop pattern. Today, you go to any place in India, changing crop pattern is extremely difficult. You cannot ask the farmers to change the crop pattern. Vidarbha region, for example, they grow huge amount of sugar canes, which is water intensive. Vidarbha is a drought prone area. They want to stop sugar cane and they want to produce something which requires less water, but the farmers are not ready, government is not ready, the sugar lobby is doing. Now, that the Harappans could do it, it actually means that probably the societies were much more participatory in nature, okay? They were not fighting like modern civilized mankind. We have all good science, all good technology, but we have Ukraine, we have this, you have that, and we keep on fighting, we have politics, okay? And it never brings us to a convergence, okay? We can never agree for anything. But this is a very classic case that where over 2,000 years they survived by doing this thing. Not only these things, they adopted very advanced kind of technologies, which I will be showing a few slides. So although that the Daily Mail London was very euphoria, with a great euphoria, they brought that Indus Valley civilization may predate Egypt's pharaohs. I don't personally think that is a very far-fetched as the journalistic, what you call, over-exaggeration, I would say, okay? But notwithstanding that, one moot question had been always bothering me is that for these 2,000 years, okay, they survived, but why did they suddenly disappear? Now, for this, Virana could not give us the answer because we didn't have the samples well into that because it was only mature Harappan and did not have the late Harappans, and after that the Indus Valley civilization dies out. So we went to a place in deep Rann of Kutch. This is the greater Rann of Kutch, is a place called Dholavira, which is India's one and only one exposed Indus Valley civilization city, which you can go as a tourist and see, okay? And if you look at Dholavira, this is again, Dholavira is somewhere there, as you can see, in the northern Rann of Kutch, almost in the southern fringe of the third desert. The white dotted lines are the rainfall isohydrates, 500 millimeter rainfall annually, 400 to even less than 200 millimeter rainfall, almost arid, hyper arid. As you can see from the landscape, no rainfall occurs there, okay? And within this run, you have these kind of beds, the rocky beds, okay? And these Dholavira, they built 5,500 years back on one of these rocky islands called the Khadir Island, okay? Very interesting. Why did they go and how did they survive for 2,000 years? So we went to Dholavira. This is, for example, I will just quickly go through some of the, pictures of Dholavira. This is the fortification wall. That means that any ancient settlements, the first thing they will do, they will make a defense structure, almost like, your fort, okay, as you see in Rajasthan. So they will make a defense structure. This Dholavira was originally excavated in 1968 by J.P. Joshi, and later on it was taken over by Dr. R.S. Bist, who is still very active at 80 plus, and therefore I had no hesitation to talk to him because he is the discoverer of Dholavira, and then started our collaborations. Okay. Now this is a Google map of how you look at the Dholavira from the top. It has two rivers, right hand side one river, left hand side one river, and this is the mountain top on which they had built the city. The city had a castle. Castle means probably the most influential people used to live there. They had a middle town, okay, where little lower hierarchy people probably were staying, and lower town, where still lower hierarchy. So probably there were, different kinds of activities were going on in these. And this kind of structure you find in almost all the Indus Valley civilization side, whether you go to the Harappa, whether you go to the Mohenjo-daro and things like that. On top of it, what you find in the eastern side, and as well as the southern side, you see they built huge reservoirs. Why these reservoirs? These reservoirs are not ordinary reservoirs. These reservoirs are big, but these reservoirs are also connected through each other. Okay? That means if one reservoir is full, it will be immediately water will go to the next reservoir and then to the next reservoir, meaning that they are very conscious about the water conservation. And that only tells you that probably water was a very scarce commodity even during that time when the monsoon was continuously. This is what the present day, river bed at Dholavira looks like. There is no water at all. Rainfall is virtually zero. And only when little bit rain takes place, you get some kind of debris flow, and that's about it. It dries up in 1 or 2 days, okay? This is what you call the east-facing entry gate of the castle, okay? This is the gate. You can see a pillar element. Probably there was a gate. Gate is gone. I don't know what kind of material they made the gate. But if you look at the civil engineering of this pillar, you will be amazed actually. The arcs are perfect. Okay, perfect arcs, okay, on either side. And this is a time, remember, when iron was not discovered. This is the Bronze Age. And copper being a soft material, it could not have been used for polishing the rocks. So how did they polish? Okay? But as you go through Dholavira, you see a series of such interesting things. Arterial road. You have a very well-planned houses like our 2-bedroom, 3-bedroom, what you see in today's cities. They had dug wells. They have water tanks. They have step wells, and they had extensive drainage systems to the extent that they even had manholes. What does it mean? It means a very sophisticated water management system in Dholavira at a place which is inhospitable today, okay? And finally, the largest reservoir, East Reservoir, which I was talking, you can see the steps, and these reservoirs, they were using for conserving the water. Large number of pots and potsherds have been discovered from the Dholavira. Okay? Variety of ornamental beads made up of variety of stones. A very precise weight system. Okay? The seals, all telltale features of kind of mimicking the modern kind of approach that the human being has. You have shell bangles, okay, made up of conch. Gone today from rest part of India, only in Bengal and Bihar, women wear these shell bangles, okay? But interestingly, Indus Valley civilization site, you will see a plenty. There are factories where they were producing these shell bangles. Neither in Rajasthan or Gujarat women wear the shell bangles. I don't know how it got concentrated in eastern part of India. Bronze Age metals, starting from copper crucibles to fish hooks to spearheads, even the gold ornaments, silver coins, and what they did, because these copper ores have various kinds of trace elements like lead, they studied the lead isotopes, okay? And these lead isotopes can tell you from where the copper ores were brought. And it looks that they were brought from far off places of Gujarat itself, as well as Haryana, Rajasthan, or even Oman. Okay, Oman is a country where you have a lot of copper deposits are there, okay? So, there must have been very concerted effort of bringing these ores, smelting these ores, and making this kind of materials. Okay, and of course, the most fascinating thing is the mankind's oldest signboard made in mineral gypsum. Okay, gypsum is a very soft mineral. If you keep it for a long time, it gets decomposed. Okay, somehow it survived, and of course, you have burial mounds where after the death they used to bury, and along with the burial mounds, they also used to give a lot of offerings, after death offerings, and large number of such cemeteries have been found in Dholavira. Okay, now question again is that in the run, white run which they call, why they built this city in the remote desert. So a team of scientists from Deccan College, Physical Research Laboratory, Kutch University and IIT Kharagpur, we went and did very extensive work, part of which is published, part is still being published. This is the composite picture of what you call of Dholavira. This is one trench, this is another trench, this is another trench. Trench means you dig continuously and get the materials vertically, almost the same way we do in geology, and we start dating the materials. I will summarize. The settlement at Dholavira started around 5,500 years before present. Rapidly they started expanding. The city was expanded. Okay, they made lower town, middle town, all these, they made reservoirs. Came somewhere around 4,300 years, suddenly the city, the expansion stopped. Expansion stopped, city was not being able, they were not being able to maintain the city, and eventually somewhere around 4,200 years, the entire city collapses. Collapses and gone, they desert the city. You see a occupational, a depositional gap there, okay, which we call in geology hiatus. And then again they come back somewhere around 3,800 years or so. But when they come back, those people are very, very primitive. They had no sophistication of these people who are living before. Okay, so this was a very startling thing, and we wanted to probe this. Oops, sorry. Now this one, as you see this dating, what I showed here, is basically the Archaeological Survey of India had actually applied to UNESCO, for heritage site. Okay, and as you know that the UNESCO assess whether a particular place will be heritage site, it can be declared or not. So this chronology, I think, helped a lot, and in 44th session of the UNESCO World Heritage on 27 July, the Dholavira was given a status of World Heritage Site. Okay, till date, as you can see the dots, about 1154 such sites are actually there. So what did we do? At different levels, we found out these shells. Okay, seasonality I mentioned. So we started analyzing isotopes and their seasonality reconstruction. Where do present day these shells live? They live like this. If you go to any mangrove, you go to the Sundarban Delta, you go to the mangrove regions of the Western India, you will be finding they are growing today. In Kutch, they were not there today, because Kutch is a desert. So the first thing, conclusion, the occurrence of this means the water was there, some kind of mangrove system was there, and that is how these people were collecting this, mainly as basically the food source. Okay, many places, for example, even today we eat from the supermarket mussels. So these people also use, even today the villagers use these snails. So these people were using them as a food source, and as you take the archaeological materials, they come out from the materials, and then we start studying the stuff. When we study these, few important things we find out. One is that the mangroves were there, okay, seasonality was there, and the monsoon was very prolific, okay. And as you can see here that this mollusk, this is also a mollusk, they grow like this, okay. As they grow up, they grow like this, and as they are growing, these environmental isotopes registers in them the climatic parameters. So it's like a past camera, okay. In the shell there are past camera, and you are trying to find out the seasonality. The most interesting thing what we found out, that okay, there were mangroves, there were freshwaters, probably some rivers were there in the run of Kutch, and These water had substantial component of glacial meltwater. Now, where the hell in Rann of Kutch glacial meltwater will come? Okay, because it is so far up from the glaciers. We kind of reconstruct a picture like this in Rann of Kutch somewhere in the early Harappan to mature Harappan time. Okay, where people were basically collecting these materials, they were eating and then they are throwing, which becomes part of the archaeological remains. But most important thing is that this river water near the Dholavira had substantial glacial meltwater. Okay, we were scratching our head. Okay, it was good that during this good monsoon period, as the this artist to depict that they had a good agriculture, they had a beautiful market and things like that. But then came a massive drought. You remember that I said that around 4,200 years that city collapsed, and monsoon became not only weak, there was a mega drought over 200 to 300 years, around 4,000 years. Therefore, probably there was a resource crunch, water reservoirs were abundant, and eventually Dholavirans or the Indus Valley people were very resilient over 2,000 years, could not sustain this major drought which is spread over 100 to 200 years. Now, two questions have to be answered. As I said, that what kind of river system it was. Okay? The most probable candidate is some distributary of the river Indus that debouched into the Rann of Kutch. Was there any river? You read some of you get in the, College Street or many places this book, Al-Biruni's, Indian travelogue. You will see Al-Biruni when he was moving through Gujarat and Kutch, he mentions that there were rivers in the Kutch. But today there is no river. But when the Indian Space Research Organization people, they started studying the satellite imageries, this is the Indus River. The black colors are basically the riverine paleo channels. Okay, this is the Indus, and this is what the river channels around this is basically the Thought Desert. This is Jaisalmer is here. This is Indira Gandhi Canal. So they named, of course, Paleo Saraswati. I do not know whether it is a Paleo Saraswati or not, but apparently there was a riverine course. Okay, this riverine course was directly coming into the Rann of Kutch. If that is not convincing enough, let us look at a 1746 British surveyor map of Mughal period. Okay, this was a British surveyor or a geographer, H. Moll, who was entrusted, okay, by the Mughals for making a map of India, okay, or India and Pakistan. You see, this is the Indus River. And look at this parallel to the Indus River, there is another river course. This is another river course, okay. What is this river course? This river course today almost is dead. This is the Nara River, okay, like we have a Narmada Canal, Pakistan has given a bund on Nara River, therefore, and they have made a Nara Canal project. The river does not flow anymore and is completely gone. Probably this Nara River was carrying the water into the Rann of Kutch, and around which the mangroves were basically developing during this time. Okay, and glacial water? Yes, glacial water because it is a distributary of Indus River. If you go to the today's Indus River and collect the water, you will see that majority of the water is actually derived from the glacial meltwater, even up to its lower reaches, which is completely different from Ganges. Ganges also gets meltwater, but only in the upper reaches, because in the lower reaches it gets a lot of water from monsoon sources, so it loses its glacial character. But Indus never loses its glacial character even just before reaching the Arabian Sea. Okay, it is possible that this Nara was very active, or the distributaries connected to the Indus was very active, and therefore those were the places where the people were collecting this kind of stuff. Second is, of course, it looks like an aridity. Was there a major aridity? In 2018, the geologist came and declared a new age in the geological time scale, which they gave Meghalayan age. Okay, a new phase in the history of the earth. Okay, and interestingly, the Meghalayan age nomenclature comes from studying a cave carbonate from northeast India in the Meghalayan cave, and it looks like that it is not only in India, it is a global phenomena that around 4,000 years to 4,200 years, about 200 years, there was a massive drought all across the globe. Certainly in the tropics and the subtropics, probably in the high latitude, they started getting this drought evidence even in the European subcontinent. Interestingly, this 4,000 to 4,200 years, not only this Indus Valley civilization disappeared. No. If you look very closely, this disappeared, this disappeared, this disappeared. Okay? Till that, this kind of studies have not been carried out in Yangtze River, Mesopotamian or Egyptian. I'm sure they must be getting the, but let me just show you at the time configuration of the Indian Indus Valley civilization sites within India. Okay? For example, Kalibangan in Rajasthan, Rakhigori, for which Dr. Sinde is going to talk, and this is your Dholavira. You see, this is a violin diagram, basically a frequency kind of diagram. It starts somewhere, as you see, around 5,300, 5,500 years. This is the mature Harappan time when the cities were built, okay, and expansion took place. And come around 4,200, 4,100, Meghalayan stage, they all zoom, they are gone. Okay? They're gone. All the cities within India, they basically collapse. And simultaneously, not only the Indian sites of Indus Valley civilization, all the major old world civilization also collapsed almost nearly at the same time. Why? The reason is very simple. Already, you know, we had a decreasing monsoon, explainable in terms of climate modeling as a solar insolation driven thing. Now today, the understanding is that these decreasing monsoon, as much as it was decreasing the monsoon over India, you know, Africa also has a monsoon. You must be knowing, Africa also has a monsoon, okay? So this monsoon system was very strong in Africa also, but as much as it was going, you know, it was becoming weaker in India, it was also becoming weaker in the African section. And then the Sahara, which was a green Sahara one day, suddenly crossed a threshold and became a Sahara desert. Okay? So they called it is a basically end of green Sahara. And how do they do it? They do it essentially by general circulation model. The climatologists do modeling for today's monsoon. They also started doing modeling for the past monsoon. Okay? And the reason they talk about this mega drought in mainland Southeast Asia is because the green Sahara suddenly collapsed, because, you know, climate is changing not gradually. Climate has a threshold and it will flip over if the threshold is crossed. And this is what is the modern day IPCC is also warning us, that we might think that the climate change is gradual. Okay, Baba, temperature is rising, but you never know when this major flipping will take place. The prediction is that by 2030 to 2040, the tropical biosphere will collapse. If the tropical biosphere, especially in the ocean, collapses, the entire food chain gets haired. Okay? So the kind of evidence which we get from the past has enormous bearing what can happen in future also. As you can see, the IPCC projection shows that the drought and crop failures are continuously increasing. Okay? You are experiencing now the South Bengal has got less than 30 to 40% rainfall than it is today. Not only in South Bengal, it's the UP, Bihar, everywhere there is a deficit rainfall. IPCC also predicts that by end of the century, the temperature of the planet will increase if the business as usual CO2 is there, something like 5 degrees centigrade. It's enormous. If your surface air temperature is 5 degrees centigrade higher, it could cause catastrophe, okay? If we have today hottest day in 20 years one, we will have hottest day probably in every 1 year or 2 years, and not one, even two, okay? It depends on how we control what you call the CO2, or if we can at all control the CO2 emissions or things like that. So in a way, Dholavira presents a classic case for understanding how climate change can increase future drought risk as predicted by the IPCC group. Now, the question is, of course, where the Dholavirans went. So collapsed, but the people who are there, people who are living, where did the people go? Okay? Now, if you look at the settlement pattern, this is the early part, all the red dots. So many sites have been discovered. Okay? You can see that starting from the western part, the central part to the eastern part, everywhere settlements were there. Good monsoon, very nice agriculture, so people were building cities and the suburban areas and things like that. Come, in the what you call late Harappan, when the monsoon became weaker, you see majority of the sites are abandoned, and they started moving in the eastern side. Okay, they started moving in the eastern side. Okay, why they were moving in the eastern side? Because the monsoon over a century time scale, monsoon slowly retreats. Even today, for example, as much as monsoon front moves from south to north, it also retreats. Okay, so that is why we get monsoon till, for example, even in the beginning of October, okay, which we call the return monsoon. The same thing happened over a large scale also. The intertropical convergence zone, which drives the monsoon, okay, it slowly was retreating. So when the western part was unlivable, the eastern part was still livable. So probably they were migrating towards the eastern side. And we indeed found in the deep run of Kutch, you can see in the desert, these sand dunes, you can see the settlements. And the settlements age somewhere around 3,200 years, 3,300 years. And this is the time when advent of iron working comes. These are the site very close to Pakistan border. One cannot work there without the help of Indian Army. Okay, very inhospitable place. But you can see they had built up small settlements. Okay, all these settlements, what we found, have iron nuggets, iron materials. So after the collapse of the Bronze Age, the ushering of the Iron Age is there. So in a way, one can say that it did not really collapse. Basically, following the Indus Valley civilization collapse, there was a massive migration from the western side to the eastern side. Okay, so again, journalists in euphoria, they started telling that Gujarat Harappans were the first climate refugees, and probably they indicate kind of warning which can happen in finding. In Gujarat, the early Iron Age settlements are not there. Okay, there is a time gap somewhere from 3,000 years to 2,500 years, and the earliest one found around 2,600, 2,700 kind of things. Okay, in Indian history, this period is actually known as a Dark Age. Dark Age means a period about which we do not know much. I think this is a period when massive migration was taking place in Indian subcontinent, within the Indian subcontinent. But outside the Indian subcontinent, I'm not expert of genetics, but I just quote one line from Professor Varghese Narasimhan's paper in Science, The Formation of the Human Populations in South and Central Asia. We reveal a parallel series of events leading to the spread of steppe ancestry to South Asia, thereby documenting movements of people that were likely conduits for the spread of Indo-European languages. Now, I must tell you, I must also caution you that this is a highly contentious issue, so I will not, because it's not my expertise domain, but the map they give, look at the timing, somewhere around 3,300 years BCE, which is the kind of Karim Shahi, where we got the Iron Age settlements, southern Thought Desert, is almost a similar time. So whether or not such a large-scale migration was taking place, I am not sure, but certainly within the subcontinent domain, there was a migration from the west to east. Okay, so that is certainly clear, and it tells you only one thing, that today's climate change, all the predictions what IPCC are making, it had already happened. Maybe man was not there, fossil fuel was not there, nature was cruel enough to drive the climate change. Okay, and those climate change records are there. Evolution of those human settlements are there in front of us. Whether we, learn from it or not, that is to us. And it is also to us whether these 200 years old modern civilization will survive for another 2,000 years or not. If you believe Stephen Hawking, he is a doomsdayer forecaster. He says, unless mankind find another planet, habitable planet in the solar system, on Earth, human being is going to be extinct. The very famous statement of Carl Sagan that extinction is the rule and survival is an exception. Okay, so I would stop my talk here today. I just would like to give some thanks to my collaborators from ASI, Professor Beast, from PRL, Deccan College, Kutch University, Calcutta University, and a host of undergraduate and graduate students of PRL. And we got a lot of funding from, especially from Infosys Foundation, DST, CSIR, and so on and so forth. And we had a host of institutes which we have been collaborating. And I must tell you that this is such an inhospitable place. Without their help, I just could not have put my footprint there, okay? So thank you very much for your patience.
Sarkar. Thank you, Professor Sarkar, for giving a very brief insight into this specific topic. So I think one or two questions.
Yeah,
quick
sure.
Yeah. So one or two quick questions, please.
Yes.
Please.
Professor Sarkar, thank you very much for a very illuminating talk, extremely interesting. I was wondering, the present day, I mean, you uttered a warning about present day, about global warning and how we can face the same fate and possibly move on to the path of extinction. But at present we know that it's global warming that's anthropogenic, that's caused by carbon dioxide in the atmosphere, that's man-made. And obviously you mentioned that that was not the case during the Meghalayan stage. And I was wondering, we know that there are several other reasons for sudden climate changes. One, of course, is Milankovitch cycle. The other is, of course, change in ocean current patterns. So has there been any study on those things to find out what really caused this massive climate change during the Meghalayan stage?
One of the thing I mentioned is that the Nature paper which I mentioned, Nature Communication, they try to do climate modeling. See what they do basically, climate modeling, they tweak with the parameters. So they will change CO2, they will change sea surface temperature and all. And so what they found out by tweaking the modeling that probably the solar radiation suddenly was stopped. Okay, then they started looking at the records of the Sahara climate, okay, for the local lakes and all. And those climate shows that there was an abrupt shift in climate. And when they match their modeling study, they probably tell that that if you suddenly collapse, you have a low monsoon, your vegetation is decreasing, but climate does not, as per their modeling, the climate probably behaves like a switch that suddenly it flips over, that there is no going back again, okay? There is no going back. So the Green Sahara collapses. So what you do, you expose the bedrock. So you have a huge amount of dust. So the dust goes into the atmosphere as aerosol. So you cut off the solar radiation. The moment you cut off the solar radiation, this Hadley cell which drives the atmospheric circulation becomes weaker. This is one of the mechanism. But till date we do not know. This is the only paper which has come till date. We are working jointly with IITM Pune and JNU climate modelers because the problem is that in India, very few people do past climate modeling. Most people work on modern climate because they are interested in modern monsoons, okay? So, but I think slowly it is developing and I think it's a very, very important field which will come over. But one thing IPCC, even based on the modern modeling, they have suggested that already there are a couple of papers in Nature that shows that don't think that the climate change is going to be global. This will be catastrophic change. And catastrophic change means, you see, for example, the melting of the Arctic ice sheet. Okay? We know for last 20 years it is melting. Okay? About 30 to 40% have already melted. Now what they are telling that don't think that it will be that spread. It will come a day when probably 70 or 80% will melt in a very short time. So that is what the danger is actually in climate change, which common people of course will not understand. Even the politicians don't understand actually. Okay? There's many politicians, even Trump does not believe in climate change. No, it is what they're telling that is not a solar event. The solar radiation was going down anyway because of the sun-earth orbital geometry change, which is known, which as I was telling in the Milankovitch cycle. So you had a monsoon decline, as I showed, right from the, when the Harappans were building, monsoon was going down. Otherwise, in Dholavira, when they built such a beautiful city, why they would be so cautious about the reservoirs? Why this is the sudden? Because the climate entire system probably switch over. It flips. It suddenly flips. Okay?
Okay.
It collapses in one day.
So any other questions? Yes.
Is there any evidence of any civilization close to Ganga before, during the time of Harappans, means in 5000, means why there is no civilization there before? Why it's suddenly
See, Indus Valley civilization, I have shown you that they have a specific extent covering India, Pakistan, and probably part of Afghanistan also. Okay?
Yes, but is
Amudarya
there any
River and all.
evidence that there is civilization in this Ganga Valley or with?
There are a lot of claims, but I don't think that it has been found. Okay?
But
I mean,
what is the
Professor
reason?
Shinde is there, he will be able to.
If the Ganga means river is already there, why not people were staying over there? But suddenly, like towards this time, they start shifting towards that, not before.
I really do not know why is it so, but basically this civilization grew along the river Indus. Okay? And the simultaneous civilizations, as I said, Mesopotamian, what they call the Fertile Crescent. Okay? So these are the places they had actually developed. Around the Ganga, at least there are no archaeological evidence to show that such old civilizations are there. The cities as old as 4,500, 5,000 years, cities in the Ganga plain, I don't think that kind of evidence actually are
Is
there.
Ganga came later, means like during that?
These are some questions which is very difficult for me to answer. I really do not know, because archaeology is a science, you know,
Okay.
you have to do a
Next
lot of
question.
things.
I have a question, but it's not related to directly this. A little bit away. Nowadays we are promoting very fast on solar energy, but if you see the solar energy land coverage is quite high, and we are targeting those areas which are dry and all, means because of these things. Is there any impact or any studies going on in that direction?
This is not my domain. I don't know solar
Okay.
energy.
Okay, so I think we are already late. I have one small question.
Yes.
That you have told that you have many techniques of this isotope techniques to predict. So what is the accuracy of that technique? Of the predicting something, so seasonality, etc. you are predicting.
No, I did not predict. I only retrieve the events which have already happened.
Already happened, but you are retrieving, but what is the accuracy? Suppose you are telling that it is 4,200 years back
Of the age?
of the age. So whether it is 4,200 or 4,000 or 3,800
4,200 years, the typical
plus minus.
radiograph error should be at the best 100 years.
Okay.
100 years is something like that.
Okay. Thank you.
As you go old, you know, the concentration of carbon-14 decreases, so your error increases.
Okay. Okay. Thank you. Thank you. Thank you once again for giving a very nice talk. Thank you. So please have a seat.